All right, so welcome to the standard G.GPE.6. So in this notes packet, we are going to be dividing segments into a certain or a specific ratio. And the easiest segments to divide in specific ratios are horizontal and vertical line segments, mainly because we can just use our counting skills. For example, if I asked you to divide the following segment in half, and I'm going to graph this segment, 3, 5, and 3, negative 1. That's this segment right here. And basically, what we can do is to divide it in half is we can count how long the segment is, which the segment's 1, 2, 3, 4, 5, 6 units long. And so if I divide the length of the segment by 2, we get that the halfway point would be a length of 3. So your halfway point would be here. I'm going to do that in a different color, sorry. And that is the ordered pair 3, 2. And that's a vertical line segment. We could just count and divide it in half. For the next one, if I asked you to divide the following segment in half, 2, 4, and 4, 4, that's this segment right here. This is a horizontal line segment. Same thing, it's 2 units long because I can just use my counting skills, and 2 divided by 2 is a 1, so the halfway point would be 1 unit away from either one of the endpoints. And so your midpoint or your halfway point would be 3, 4. Now you heard me use the word midpoint. Midpoint is exactly what we're finding. We're finding the middle of the line segment. Now, when we are trying to find the halfway point between 2 points that do not create a horizontal and vertical line, it's not that easy. For example, if I graphed the following point, negative 1, 6, and the point 2, negative 3, we can actually not use our counting skills to find the halfway point between these 2 points on the line segment. And so it's not as simple. So we need a formula to help us divide that line segment in half. And that's going to be called the midpoint formula. Now let's look back at number 1 and number 2 and see what happened to help us find the formula. So let's look at number 2 to see what happened between my two x values. So my two x values were a 2 and a 4, and I wound up with the midpoint x value being a 3. So what mathematical thing could we do to the 2 and the 4 to get the 3? Well, I can't do just 2 plus 4. That wouldn't work. I can't do 2 minus 4. That wouldn't work. But what if I did 2 plus 4 divided by 2? So a 2 plus a 4 is a 6, divided by a 2 is a 3. That works, and if I try it for my y values on number 1, a 5 and a negative 1 to get a y value of 2, if I add my two y values together, a 5 plus a negative 1 is a 4, and divided by 2 gives me that y value of 2 there for my midpoint. So that actually works. So your midpoint formula, we use capital M to represent midpoint, is x1 plus x2, so your x values added together divided by 2 would give you the x coordinate of your midpoint, and then y1 plus y2 divided by 2 would give you your y value of your midpoint. So let's try it with number 3. I'm going to label my points x1, y1 and x2, y2. And so my midpoint on number 3 would be x1 plus x2, so a negative 1 plus a 2 divided by 2 for my x values, and y1 plus y2, so a 6 plus a negative 3 divided by 2 for my x values. So simplifying now, a negative 1 plus a 2 is a 1, and a 1 divided by a 2 is just a 1/2. And then here, a 6 plus a -3 is a 3, and a 3 divided by 2 is just a 3/2. So that's the same thing as 0.5 and 1.5. So if I were to graph 0.5 and 1.5, that's about here, which actually does look correct, about halfway between the two endpoints. Now there's no way that you would have been able to estimate that point just by looking at your segment and trying to use your counting skills. So we do need this formula for when we are dealing with a segment that may not be a horizontal or vertical line segment. So make sure to know this formula very well. So number 4, it says to find the midpoint of PQ, and it gives you the endpoints of PQ. I'm going to label my points x1, y1, x2, y2, and I'm going to use my midpoint formula. Midpoint, we use capital M to stand for midpoint, and we're going to do my x1 plus my x2 all over 2, always divide by 2, and my y1 plus my y2 divided by 2. So I wind up with my midpoint being a 2 plus a 10 is a 12 divided by 2 is a 6, and a 4 plus a 6 is a 10 divided by 2 is a 5. So my midpoint is 6, 5. Now number 5 is written differently. It says to divide the segment in half. That still means that you're finding the midpoint. So I'm going to label my points x1, y1, x2, y2, and I'm going to use my midpoint formula, which is x1 plus x2 divided by 2. And then for the y value, y1 plus y2 divided by 2. Simplifying to find the actual point, a 16 plus a 6 is a 22, and a 22 divided by a 2 is an 11. A 12 plus a -2 is a 10, and a 10 divided by a 2 is a 5. So that's my midpoint. And then number 6 is also written differently. It says to divide the segment ratio, or the segment into the ratio 1 to 1. So what that means is that if I had my segment -2.5 and -8.1, actually it would look somewhat like this, where D is here and C is here. This is just a rough sketch. Dividing that segment into a ratio of 1 to 1 would mean that I'm finding the midpoint, because I want the ratio to be 1 to 1. So what that means is that I want whatever I get for DM to be equal to MC, and that would get me a 1 to 1 ratio. So I'm really finding the midpoint here. Even though the directions are different for each of these, we're still finding the midpoint. You need to know what each of the directions mean. So labeling my points x1, y1, and x2, y2. So I have an x1 value, which is -2, plus my x2 value, which is -8, divided by 2. And then my y1 value plus my y2 value divided by 2. So my midpoint, -2 plus a -8 is a -10, divided by 2 is a -5. And a 5 plus a 1 is a 6, divided by 2 is a 3. All right, so that brings us to the end of the level 1 lesson.